Welcome and thank you for always joining us. This is K.c.s.e 2005 paper 1 question number 21, a question on integration. The question we have reads the gradient of a curve at a point xy is 4x minus 3. The curve has a minimum value of negative 8. Part A, find from and 1 the value of x at the minimum point. We know what we have is the dy over dx, which is the gradient function, and the gradient function is 4x minus 3, and we need part A, the value of x at minimum point. We know at minimum point, or at minimum or maximum of anything, the dy over dx is usually 0, and therefore if we take 4x minus 3, this one will be able to give us 0. If we move negative 3 to the other side, 4x is going to be equal to 3. Divided by 4 on both sides, x is going to be 3/4. And that is the x, or the value of x at the minimum point. Whereas negative 1 over 8 becomes the y coordinate. We go to Roman 2 of part A. We need the equation of the curve. Remember, to get the equation is usually in the form of y, and therefore we are going to integrate 4x minus 3 in respect to the change in x. In this case, y is going to be equal to 4x. This is raised to power 1. We add 1 to the power, then we divide by the total new power, which is 2. Then minus 3. We introduce x, then a constant of integration. 2 goes to 4, 2 times. That means y will be equal to 2x squared minus 3x plus c. Once we have gotten the general equation, we can move and get the specific equation by getting the value of c. Remember, the value of x is 3/4, and that of y is negative 1/8. Using the x and y coordinate at minimum point, we can get the c. So in place of y, we are going to place negative 1/8, which is going to be equal to 2 into x. The value of x is 3/4, but it is squared, minus 3 times x, which is 3/4, plus c. So this one is going to give us negative 1/8 being equal to 3 squared is 9. 9 times 2 you get 18. Over 4 squared will be 16. Minus 3 times 3 will give us 9. This one will give us 9/4 plus c. So if we move all this to the other side, we are going to have negative 1/8 minus 18/16 plus 9/4 being equal to c. And therefore, using a calculator, you take negative 1/8 minus 18/16 plus 9/4, the value of c is going to be equal to 1. Once we have gotten c, we can therefore now write the specific equation, where y will be equal to 2x squared minus 3x plus c, and the value of c is 1. And at this point, we have worked out part A, Roman 1 and Roman 2. Then we move to B, part of the question. We are told P is a point on the curve in part A, Roman 2 above. If the gradient of the curve at P is negative 7, find the coordinates of P. We know the dy over dx has been given to be 4x minus 3, and we have been told that the gradient is -7, and therefore you take 4x minus 3, you equate to -7. You bring -3 to the other side, we are going to have 4x being equal to -7 plus 3, meaning 4x is going to be equal to -4. Divide both sides by 4x is going to be equal to 1. And at this point, when x is equal to -1, then y is going to be equal to, we take it to the function 2 into x is -1, we square, minus 3 times x, which is -1, plus 1, and in this case we are going to have -1 squared, which is +1 times 2, which is 2. -3 times -1 will give us +3, plus 1, and this one gives us 6. And therefore in this case the coordinates of a point P will be -1 and of course +6, and that becomes the solution to that particular question. Once we have tackled that, we can again move to the next question. The question that was done in K.c.s.e 2006 paper 2 number 15. The question we have reads, a particle moving in a straight line passes through a fixed point O with a velocity of 9 meters per second. The acceleration of the particle t seconds after passing through O is given by A is equal to 10 minus 2t meters per second squared. Find the velocity of the particle when t is equal to 3 seconds. For us to get the velocity at the time 3 seconds, we need to get the velocity function by integrating 10 minus 2t, and in this case velocity will be equal to, we take 10 introduce t minus 2t, this is right, it is raised to power 1. We add 1, we divide by the total new power, then we add c, which is a constant of integration, meaning v will be equal to 10t. 2 and 2 will cancel, giving us minus t squared plus c. We know that when velocity is 9 meters per second, then the value of t will be equal to 0, and therefore using v and t, we get the value of c. V is 9, which is equals to 10 times t, which is 0 minus 0 squared, plus c, meaning that our c is going to be equal to 9. Therefore, the specific equation for velocity will be 10t minus t squared plus 9. At this point now, we can be able to get the value of t, the value of v. So at t is equals to 3 seconds, then velocity is going to be equal to 10 into t, which is 3, minus 3 squared plus 9, and this one is going to give us 30, minus 9 plus 9. Minus 9 plus 9 will give us a 0, and therefore 30 minus 0 will give us 30 meters per second as the velocity of the particle at t is equals to 3 seconds. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.